Gisborne is probably recognised by two features more than any other: the statue to commemorate Captain James Cook's landing on New Zealand soil, and the town clock. Everyone knows where the town clock is, as it's often used as a landmark, and the retailers use the phrase when advertising, "in the block, by the clock." But apart from that, the town clock does provide a service, and most towns and cities have their own town clock for the same reason. Apart from a 1-hour rest each March for daylight saving adjustments, the works have kept going almost continuously since early 1934. Okay, let's find out what makes this thing tick, as there are some very cunning ideas in its operation. Made in England by Jensen Company Limited of Leicester, the clockwork is electrically operated on the pulse sync system. Here we have the master clock, the mastermind of the whole system. Like a grandfather clock, it has a long pendulum, which in this case is kept moving by a lightly weighted gravity lever every half minute. The movement of the pendulum pushes around the scape wheel, tooth by tooth, through a driving pawl lever. At each revolution of the scape wheel, which occurs every half minute, the driving pawl engages a deep tooth. The right-hand extended end of the lever, instead of passing through the gap in the stirrup arm, pushes the stirrup to release the gravity lever. A small piece of felt absorbs the shock and prevents the lever from bouncing back off the catch. The roller on the gravity lever rolls down the inclined face of the pallet on the pendulum, giving it a gentle push. The gravity lever continues until these contacts meet and an electromagnet is energized, attracting an armature, and at once the gravity lever is replaced back onto the stirrup catch. Any small time adjustments required are made with the scape wheel. Each tooth represents 2 seconds. If slow, you hold the wheel and let the lever take 2 teeth. If fast, you lift the back stop and let the lever miss a tooth. To regulate the clock, an adjustment is made to the bob weight on the pendulum with the graduated wheel. Small shim weights will fine-tune the timing. Placed on top will speed the pendulum up and vice versa. Now the contacts also control the slave units wired in the series circuit, and this wiring is the only link from the master clock to the tower clock. The hands of the master clock are moved by one of the slave units. The whole system is extremely accurate and very reliable. Come on top and we'll have a look at the works up there. The tower was designed by Mr. E.R. Thomas and built by a contractor, Mr. H.T. Reynolds, by October 1933. The tower is 56 feet 3 inches tall on a pad 15 feet 6 inches square and 18 inches thick. There are 2 flights of stairs, but watch your head at the top. This is the tower clock, where the center of the clock face is 38 feet from ground level. Faces are 5 feet in diameter. The 4 faces, hands and related gearing, and the bells were acquired from the old Gisborne post office, where they were first used in 1904 and then removed with the tower after the 1931 Napier earthquake. Now this tower clock incorporates a waiting train movement, because the train of gears operating the hands, spindles, remains static for approximately 3 seconds in every half minute. Note the counterweights on the hand shafts and the 60-to-1 gearing. The motive power for drawing the hands comes from this free swing pendulum, which is energized electrically when its oscillations fall below a predetermined arc. This pendulum is entirely independent of the timekeeping part of the master clock and merely has to supply the energy to drive the hands by means of the associated pawl, ratchet and worm gear. Hands are geared to move through 1/2 minute on the faces in about 27 seconds. The driving pawl here is automatically disengaged from the ratchet wheel and the gear train by the masking lever. They wait for the timekeeping element from the master clock below to take over at the exact 1/2 minute to which the hands are pointing. The electric pulse when the master clock points close operates the release relay, which releases the masking lever and ratchet wheel, and the hands are in motion again for the next 27 seconds. The waiting train movement can be regarded as a power pendulum operated slave clock, which is corrected to the exact time every 1/2 minute. The power pendulum is kept going with this cunning device. Note that this toggle fixed to the pendulum drops into the V block and closes a set of points, and operates the drive magnets timed to pull the pendulum to its full swing. This action could go on forever until the battery goes flat or something stops the pendulum. This other slave unit, operated from the master clock, times the striker and the Westminster chimes. When these reed contacts close, power goes to this set of contacts, which are timed to close about 15 seconds before the minute the chimes are set for. The low voltage operates the 230 volt main switch to the motor, driving the geared cams which operate the bell rods. Striker motor is timed with these contacts in the slave unit, and the first strike is set to the last signal peep from the radio time signal. Okay, we have the bells going. To stop them at the required time, the contact arm rides on the edge of this slotted wheel. The power's cut when the arm falls into the slot. The 24 volt batteries keep the clocks going, and the overall power consumption is extremely small. The batteries are kept trickle charged from the 230 volt charger at an average of 26 volts and 8 milliamps. Most of the system is original, and it's extremely accurate, within 1 or 2 seconds a week. A worm and pinion had to be replaced in 1978, and the old 20 volt acid batteries replaced with 24 volt NiCad batteries. J.R. Taylor and Company, Leicestershire, England, famous for centuries, made the 4 bells, producing the Westminster chimes. This, then, is the Gisborne town clock. Some would say it's what keeps Gisborne ticking over.